Hello, I'm Bernhard Frank, owner and managing director at HID Europe. We at HID design, manufacture and install quality energy hybrid systems. These systems offer large economic benefits if installed in applications where electric energy is being produced by diesel generators. This does occur in areas where there is no public electrical grid available or where the grid is unstable and has a lot of outages. The most critical component of every hybrid system is a storage battery. For this reason, we have chosen our longtime partner Hitachi Chemical from Japan to be our battery supplier. The batteries manufactured by Hitachi Chemical are the most advanced lead-acid storage batteries in the world market today. Not only do they offer outstanding cycle life with 4,500 cycles at a DOD of 70%, but also the cost of storing and delivering energy is less than 10 euro cents per kilowatt hour. Therefore, we can offer the highest reliability with the lowest overall cost. The battery life is typically between 15 and 17 years, but by this time, other lead-acid batteries have to be replaced twice. Our systems range from 20 kilowatt to 5 megawatt in output, with storage capacities from 50 kilowatt hours to 25 megawatt hours. We have installed a significant number of systems operating in Europe, Africa, Australia, Indonesia, and Brazil. Please refer to our website for further information on our running projects. Thank you. The battery life is typically between 15 and 17 years. By this time, other lead-acid batteries have to be replaced twice. Our systems range from 20 kilowatt to 50 megawatt in output, with storage capacities from 50 kilowatt hours to 25 megawatt hours. We have installed a significant number of systems operating in Europe, Africa, Australia, Indonesia, and Brazil. Please refer to our website for further information on our running projects. Thank you. The heart of our systems are the Hitachi advanced lead-acid batteries using nanocarbon particles for an enhanced lifetime. These batteries are very compact compared to conventional OPZV batteries. They come in a solid metal frame that can be stocked 4 modules high. This enables us to save installation space and also mount these batteries into standard 20 feet containers. Also, it should be noted that the batteries do not need any water refilling and that therefore the battery maintenance is minimal, which reduces the overall operational cost. The battery set which you see in this picture contains a net energy of 50 kilowatt hours, which can be extracted from the batteries over a time of 8 hours. As battery chargers, we use the Victron quattro inverters. These inverters, they can form a grid in an off-grid area, and they are able to take solar energy and store them in the battery, as well as take the energy out of the battery and feed the load. For the overall energy management system, we use the Victron color control, which has an assistant called energy storage mode. With this system, we can manage the energy flow between energy generated by PV panels or energy received from the grid, the energy that's used by the load, and the one that comes into the battery or goes out of the battery. As we can see here on the display, we're now consuming about 4.6 kilowatts in the load. At the same time, we are storing about 6.3 kilowatts in the battery. This is because our solar system produces 11.7 kilowatt. So during the daytime, we store extra solar energy in the batteries, and then this energy is dispersed to the load during the nighttime without any use of using the grid or having to use a diesel. Of course, when the battery reaches its lower limit, then either a diesel needs to be started or there has to be a grid supply. Now, let's take a look at our containerized systems. The systems we're going to show you are in production for various clients in different areas of the world. Here on the bottom, you can see the battery set, which is connected to the DC bus via a circuit breaker. And from there, we go on to the DC distribution, which is then connected to the battery inverters. On the top you see we have 6 Victron Quattros, each one having a capacity of 10 kVA installed, so that the system output power is 60 kVA. Here you can see our generation management system, and also we have signal lights indicating whether the grid, the generator or the system is functioning. Plus there's battery monitors showing the status of each battery string. At the end of the container we have our PV inverters, which take the solar energy and convert it from DC to AC, so it can be sent to the Victron battery inverters to be sent then converted back to DC and to be stored in the batteries. Each of the Fronius inverters which you see installed here has a capacity of 20 kilowatt. Of course our containers are air conditioned, they are insulated with 60 millimeters insulation, they have ventilation holes so that any gas could be taken out and evacuated from the container, and of course there is a fan. Now here in the middle, there you can see a cosinus phi unit which regulates the cosinus phi in areas or applications where the cosinus phi happens to be less than 0.85. Using this system will actually increase the available power which is there for the load. In this picture we show you the production of a battery system which has 150 kilowatt hours net, which can be taken out from the batteries within 8 hours, and a total of 90 kVA of inverter power. And in this cabinet we install the solar inverters on the right side. Here we have now 3 inverters, but there's actually space for 4 inverters to be installed. Maximum capacity of each inverter could be 27 kilowatt. Based on client's request, we can of course also incorporate an AC switchboard with multiple outlets according to whatever the customer's needs are.